if you go to our YouTube channel, you find a lot of indices videos. Okay, but since it's here, we're just going to wrap it up here. So indices is just the put algebra in power. Put algebra in power. Okay, putting in power instead of writing normal way, we raise a certain number or a certain letter to a certain number. Now they're in different phases, so we term them, we put them in laws or according to their rules, according to how they follow, according to the order of operations, we put them into different laws. The ones that have the same base and raised to a certain power and they be multiplied, we call that rule 1 or law 1, the law of indices, call it law 1. So when I say a to the power of m times a to the power of n, so this is called the first law of indices. So you have the same base and they raised to different power. What you should do, you should just write the base only once and you add the power together. If they be multiplied, you add the power. You just say n plus n. You add the power. So that's called the first law of indices, which we've done extensively in the past. So I just want us to have an overview of the first law. Now we go to the second law. For second law, instead of multiplication, we have division. So we have when we have a to the power of m, divide by, we have a to the power of m, and we have a division instead of multiplication, then this will be called second law of indices. So divide by a to the power of n, and when we have a division, you just write the base. Since the base are same, we write the base and we subtract the power. We subtract the second power from the first power, say n minus n. Okay, this is the rule for the second law. And when we have only one base, for example, if we have a base, just a base, okay, if we have hello, if we have okay, if we have a to the power of m, bracket open and close raised to power n, you see there's one power inside, there's one power outside. So when you have a power inside and a power outside, what do? You just multiply the power. You say a to the power of m times n, you get a raised to the power mn, a raised to the power mn. Is that okay? You get a raised to the power mn. Is that okay? Okay, so these are the first three laws of indices. These are the first three laws of indices. These are the first three laws of indices. So we're going to highlight them, and so that we can refer to them and revert them. So this is the first law. When we have a times a to the power of m multiplied by a to the power of n, we say it's equal to, since it's multiplication, they have the same base. What are the base? A and a are the base. You just say n plus n. And when you have a to the power of m divided by a to the power of n, you just write, division can be like this also. It's not only horizontally, it can be vertically. A raised by m over a raised by n. So it can either be like this or be like this, right? Whichever way it is, it means a to the power of m minus n. And if you have a raised to power m bracket, a raised bracket n, you should multiply the two power because of the bracket, okay? You multiply the two power. So these are the first three laws of indices. Let's take a look at some example that elucidates what we just talked about. If we have a to the power of d to the power of 3 multiplied by d to the power of 4, what we have will be, because this week we're going to apply what we call the first law of indices. We're going to apply the first law of indices, which means we write only one d, we add the power. 3 plus 4, we get 7. D raised to the power 7. Is that okay? So that's how we got there. That's how we got this one. That's how we got this one, okay? Now let's go to the second question. You have, here you're going to use about two laws. There's the third law, p raised to the power 2 raised to the power 4. There is power inside, power outside. So we're going to simplify this one. We get the p raised to the power 2 times 4 is 8. So we're going to get p raised to the power 8 in the numerator. In the denominator, we apply the first law. We say p raised to the power, in the numerator, in the denominator, we apply the first law. We say p raised to the power 2 plus 4, which is 6. So numerator will be p raised to the power 8, and denominator will be p raised to the power 6. That's what we got here, p raised to the power 8 and p raised to the power 6. Now we apply the second law, because this is division. You see, how many laws have we applied? We applied third law here, first law here, and then after that, we apply what we call the second law. P raised to the power 8 minus p raised to the power 8 divided by p raised to the power 6, it becomes p raised to the power 8 minus 6, which gives us p raised to the power 2. Is that okay? So that's the application. So you pause here, you try to solve all of these questions. It's not a big deal. If you have numbers, the numbers will cancel. 6 divided by 3, you get 2. So you will have 2 here. Here and here, a raised to the power 6 and a raised to the power 2 is a division, it's second law. So you say a raised to the power 6 minus 2, you get a raised to the power 4. And then here you get b raised to the power 4 divided by b raised to the power 3 is the second law. So you say b raised to the power 4 minus 3, which is b raised to the power 1, which is b. So we have this divided by this, we get our answer will be 2. Okay, let's use a pen instead of highlighter to write. So our answer will be 2, because you say 3 divided by 6 divided by 3, you get 2. A raised to the power 6 minus a raised to the power 6 divided by a raised to the power 2, you get a raised to the power 6 minus 2, which is a raised to the power 4. So here we get a raised to the power 4. And then b raised to the power 4 divided by b raised to the power 3, you get b 4 minus 3, which is b raised to the power 1, which is just b. So this becomes your answer. Okay, so anyone like this, pause the video, solve all of this problem. They're not a big D, they're not big D, just follow it. Now we go to what we call the zero index. Now for zero index, we go to like apply the second law of indices, you know. We go to apply the second law. For example, if you say m a raised to the power, let's go to the highlighter. Okay, if you say a raised to the power m divided by a raised to the power n, remember we get a raised to the power m minus n, right? So what if they're both n? What will lead to 0? We want to show you what leads to 0 index. Now, what if instead of say a raised to the power m and n, we say a raised to the power n divided by a raised to the power m and n. We use m and m. So if you have a raised to the power m divided by a raised to the power m, what do you have? It means a raised to the power m minus m. M minus m will be 0, right? So we therefore we get a raised to the power 0. M minus m. If you have the same number in the power, you get 0. So anything you get 0 in the power. Anything raised to the power 0 in indices is 1. Anything raised to the power 0 in indices, a raised to the power 0 is 1. 1 million raised to the power 0 is 1 in indices. Okay. Anything raised to the power 0 in indices is 1. Okay. 200,000 times 10 raised to the power everything raised to the power a raised to the power 0 is equal to 1. So anything raised to the power 0 in index is 1. So that's what we call the zero index. That's what we call the zero index. Anything raised to the power 0, anything raised to the power of 0 is equal to 1. Now we go to negative index quickly, as fast as we can. We go to negative index. Okay, for negative index, we're going to have a negative power, meaning the first one is smaller than the second one. The first power is smaller than the second power. Then we get a negative index. Is that okay? And if we have anything like negative index, for example, if I have a raised to the power in indices, if I say a raised to the power 1 raised to the power minus m, this negative will become 1 over a raised to the power m. This negative becomes a fraction. It becomes a fractional part. Or if you have any fraction, if you have something in fraction, you can put it in power. For example, if I have 1 all over 5 raised to the power 2, and if I want to put it in power, this will be 5 raised to the power minus 2. Because anything 1 all over is negative of power. Become 5 raised to the power minus 2. Is that okay? For indices. Now let's go to quickly. If you have a raised to the power minus m, is same. The logic is same as a raised to the power 0 minus m. 0 minus m, that's why you get a raised to the power m. So which means this one is a raised to the power 0 and this second one is division. Once you have minus, you have division. Okay? So for second law of indices. So divide by a raised to the power m. So a raised to the power 0, anything raised to the power 0 is 1. That's how we got 1 in the numerator. And then we have this one in the denominator. And if you have 1 all over a raised to the power m, is same as a raised to the power minus m. Is same as a raised to the power minus m. Therefore, this logic stands. This logic stands. Any number raised to the power minus, if you have a raised to the power, okay, sorry. If you have a raised to the power minus m, is equal to 1 over a raised to the power m. Is that okay? So here are some problems for us to solve. Okay, it's not a big deal. This one is c raised to the power 0, which means 1. So 1 times c raised to the power 3 is c raised to the power 3. So it's not a big deal. Pause the video, solve all of this problem. Now we go to fractional indices. Let's go to fractional indices. Okay, remember, square numbers, you can easily find their square root for every square number. For example, if you have 16, 16 raised to power half, anything half means square root. In indices, when you raise anything to the power of half means square root. So if I say 16 raised to power half, it means I'm telling you to find the square root of 16, which will be 4, plus minus 4. Okay, there. If you say 27 raised to power 1 over 3, the denominator becomes the root, just like this one. Because this is 2, 2 is square root, 3 is cube root. The denominator of this fraction, the denominator becomes the root. Okay, let's write something like that. For example, if I say 27 raised to power 1 over 3, 27 raised to power 1 over 3, what it means is that this denominator will form the root. Since it's 3, we're going to have cube root. So I'm writing 27. I'll write the cube root of 27. The numerator will form the power. What do I mean? It means whatever number is here will be, that's what you raise it to. That's what you raise everything to. This is 1, so we raise it to 1. So if you raise anything to 1, it's same as that number, so you don't have to bother raising it to 1. If it's 2 over 3, we would have raised it to 2. Okay, so you find the cube root of 27, which is 3. The cube root of 27 is 3. 3 raised to power 1 is equal to 3. So the answer to this is 3. So when we want you to find the cube root, we can just raise it to, we say find 27 raised to power 1 all over 3. That's fractional indices. If we want you to find the cube root, we can simply say find 27 raised to power 1 over 3. What we are saying you should find the cube root of 27. Is that okay? So in general, let's take a look at this rule. In general, if you say a raised to power 1 all over n is there, it means the nth root of a. It means the nth root of a. The denominator will form the root. Okay? For example, if I say find for me 64 raised to power 3 over 4. 64 raised to power 3 over 4. Okay, how to do this? The denominator will become the root. So which means I'm going to find the fourth root of 64. The denominator forms the root. I'm going to find the fourth root of 64. And then the numerator forms the power. So meaning I'm going to raise it to power 3. So I'll raise this whole thing to the power of 3. Because the numerator is 3. So I'm going to raise it to power 3. Now, what's the fourth root of 64? What's the fourth root of 64? What's the fourth root of 64? Does it have a fourth root? Okay, does it have a fourth root of your number? Okay. Maybe 1. Let's say this number is 128. Check. 128, does it have a fourth root? 128. If we change this number to 128. Does it? Okay, let's say 512. 512, check. Okay, so you find the root and you raise it to power, whatever, okay? Okay, you find the fourth root and raise it to power. Is that okay? We'll move on. Now here, the same thing is expressed here. Here we're just showing you some example. Is they express the cube root of a to the power of 4 in this format. So what we're going to do, we're going to express the cube root of a. So we're going to say a raised to power, the cube will be the denominator. The cube, what form the cube will be the denominator. So here will be 3 and the power will be the numerator. So it will be written like this, a raised to power 4 over 3. So if they say put in this format, means it has to be a raised to power 4 over 3. Look at what they got, exactly what they got. Is that okay? So express this one, b raised to power 2 over 5 in this form. Okay, this one, for this one, the fifth root, the denominator will form the root. Right? The denominator will form the root. What's the denominator of the power? The denominator of the power is 5. So we find the fifth root of b and we raise it to power 2. The numerator will form the power. Is that okay? That's that for that. Let's move on. If you're given, they say simplify this one. If you're asked to simplify this one, we can apply first law, meaning p raised to power. We're going to add this and this together. So if you add 1 over 2 plus 1 over 3, I think you're going to get 5 over 6. 1 over 2, you're going to add 1 over 2 plus 1 over 3, you're going to get 5 over 6. Okay? So you add the numerator. Okay? So anyway, it's laggy, but let me just explain from here. So if you add this and this, you get p raised to the power 5 over 6 divided by p. P raised to the power 5 over 6 divided by p. So that would be p raised to the power 5 over 6 minus 1. P means 1 raised to the power 1. Okay, it means raised to the power 1. So we're going to have 5 over 6 minus 1. That will give us negative 1 over 6. That will give us negative 1 over 6. Is that okay? So here are some problems. Pause the video, solve all of this problem, and move on. Okay, so with that, we come to the end of our class. Pause the video, solve all of this problem, all of this. Don't leave anyone untouched. Okay, and then you're good to go. Is that okay? Thank you for joining us.